Okay, all right, you guys. Hey, so we just did another one of these dr d theta problems, and I'm going to repeat what I just said a couple minutes ago for the video camera. Yesterday, we were dealing with dr d theta, where we're interested in what is the biggest r away from the origin, what's the smallest r away from the origin. That was yesterday and this last problem today. But now today, we're going to be interested in something else. We're going to be interested in dy dx. So that now we'll be interested in, okay, where is the slope of my tangent horizontal? Or where is the, stupid thing. Where is the slope of my tangent vertical? Because it's all about dy dx. Or I'll say, okay, this point is all well and good. Get me the equation of the tangent line through that point. That's the sort of thing we're going to be thinking about today. Slopes of tangents, equations of tangent lines. So let's get started. Let me erase this. Here comes our first example. For r equals 1 minus sine of theta, get dy dx. Well, I gotta tell you, you'll never think of this, so I'm just gonna tell you how to do it. You know how you're gonna get dy dx? Just, okay, you're going to do it just like we did parametrics. Remember how dy dx equals dy dt over dx dt? Well, we're going to do the same thing. We're going to get dy d theta over dx d theta. You guys okay with that? The only problem is I don't have an expression for x or y. I only have an expression for r. Okay? Gosh, I wish there was some equation that could get me an expression for x and y given an expression for r. Is there, can someone think of one like where I have x on one side and I have like r and theta on the other side? Oh my God, you guys are right. R cosine theta, r sine theta. So guess what? You're not taking the derivative of this guy. For the numerator, you got to take the derivative of this guy. And for the denominator, you've got to take the derivative of that guy. You see what I mean? That is, you're going to have to do this. X is r, oops. R is that guy. So x is 1 minus sine theta cosine theta. And y is 1 minus sine theta sine theta. And that's what I'm going to have to get the derivative of to get what dy d theta is. You see? Now there's two ways to do this. One way would be to do product rule on what you're looking at, or the other way would be to distribute the cosine theta and then take the derivative of what you get after you distribute it. And frankly, either way is fine. Me personally, I prefer the distribution method, so I'm actually going to rename this cosine theta minus sine theta, I think I'll call it sine theta, cosine theta. Sine theta, cosine theta. And then this will be sine theta minus sine squared theta. Okay? So now that I have expressions for x and y, I can go ahead and get the derivatives of them. The derivative of y with respect to theta is going to be cosine theta minus 2 sine theta cosine theta. That's what's going to go in the numerator. In the denominator, I'm going to have negative sine theta and then minus. I'm going to have to do product rule on sine theta cosine theta. Derivative of sine theta is cosine theta, so I'll have cosine theta, and then plus the derivative of the cosine is the negative sine, so it'll be negative sine squared theta. That's the derivative of that guy over that guy. Wait, Am I okay? Yeah. You know what a common mistake people make? Is they'll write an expression for x, they'll write an expression for y, and then they'll take the derivative of the x and put it in the numerator, and they'll take the derivative of the y and put it in the denominator. So don't make that mistake. In fact, what I'm going to do for every subsequent problem is I'm going to put the y first and the x second, so I never make that mistake of getting it flipped. Okay? So anyway, that's it. That's my expression for dy dx. It's that simple. Any question or problem on that? Okay, so let's go ahead and get equation of tangent line at theta equals, I don't know, what do you want? Theta equals what? 45?
90.
90?
Yeah.
All right. Theta equals 90 degrees, which, of course, your book will probably say theta equals pi over 2. All right, let's go for it. dy, oh, by the way, you need two things to get the equation of a tangent line, right? You need the point and the slope.
Yeah.
So let's go ahead and get the slope. dy dx evaluated at theta equals pi over 2 is going to be the cosine of pi over 2 minus 2 times the sine of pi over 2 cosine of pi over 2 over, pi over 2 over negative sine of pi over 2 minus cosine squared of pi over 2 minus sine squared of pi over 2. Okay? The cosine of pi over 2 is 0. This thing is 0, so I get 0 in the numerator. The denominator, I get negative 1. This is 0, and the sine of pi over 2 is 1. So I get negative 1 plus 1, which means I get 0. So what does that mean for me?
L'Hopital's.
What's that?
L'Hopital's rule?
Yeah, L'Hopital's rule. You guys okay with that?
Yes.
So for some crazy reason, Andrew chose the one angle where I have to do L'Hopital's rule to get what it is. Now, so I'm going to do L'Hopital's rule just for fun, okay? Dy dx evaluated at theta equals pi over 2 is going to equal, I'm going to take the derivative of the top, so that's going to be negative sine of theta minus 2 times, or it's plus 2 times cosine squared theta, and then minus 2 times sine squared theta. Are you okay that I just took the derivative of the numerator? Alrighty. So the derivative of negative 2 sine cosine is going to be, when I take the derivative of the sine, I get cosine, and that'll be 2 cosine squared. Oh, that negative should still be there. What am I doing? Boop. And then the derivative of the cosine is the negative sign, and negatives cancel. So that's a plus. And I'm going to take the derivative of that guy. So I'm going to have negative cosine theta, and then minus 2 cosine theta, negative sine theta. So that's a plus. And that's minus a minus, which makes a plus. And the derivative of the sine squared is going to be 2 sine theta cosine theta. All right. Well, now let's go ahead and put in pi over 2. And I'm going to just put in pi over 2 in my head. So the sine of pi over 2 is 0, and that guy, negative cosine pi over 2. No. Wow, I'm going crazy. Sine of pi over 2 is 1, so I got negative 1. Hope I didn't make that mistake here. No, that's good. Negative 1, that's 0, and then that's 2, okay? And then this is 0, this is 0, and this is 0. So I get 1 over 0. So tell me, what kind of tangent line do I have here? Yeah, it's a vertical tangent. Vertical tangent. So you know if I've got a vertical tangent line, it's a line of the form x equals whatever. So all I need to do is plug into x. So x is going to equal 1 minus the sine of 90 degrees times the cosine of 90 degrees. So x is going to be 0, x equals 0. So there it is. That's the tangent line. It would have been more interesting if you'd chosen another one, but yeah, what can you do?
Hey, L'Hopital's rule was fun.
I love L'Hopital's rule. That's why I put the big happy face ordinarily. Hey, let me go ahead and graph this. Okay. R equals 1 minus sine of theta. Okay. And you'll notice the biggest R can be is 2. The smallest R can be is -2. So I'm going to change my window to go from -2 to 2 for the x's and the y's. And here's the graph. Okay, and trace at 90 degrees. Okay, do you see that I'm right here at 0, 0? And so the tangent line is like, as I approach 90 degrees, the tangent line becomes more and more vertical until pretty soon I get a vertical tangent. Okay, just 1 second. Thank you. Kenneth, at the end of first period. Okay, all right. Maybe it looks more obvious if I blow it up. Let me go like -0.1 to 0.1, negative, oops, -0.1 to 0.1. Will that help? Okay. Do you guys see? I just took a close-up of what happens at the origin, and do you see that it ends up actually being a cusp? So I do get a tangent line, a vertical tangent line of x equals 0. That's if I take a close-up of it. Alrighty. So, but if I go, -2 to 2, then I end up getting this thing. Okay. So, well, shoot, guys. I spent a lot of time on that because that was kind of a tricky one. Let me have you. Let me see here. Let me see. Oh shoot! I've got 10 minutes left. Yeah. Let me do this. Here, just a second. How about 2 minus 2 cosine theta? Let's see what that looks like. By the way, because it's 2 minus 2 cosine theta, you're going to have to go from -4 to 4, because that's the maximum values. So here comes, yeah, and so, let me see here, trace, 0. Yeah, I'm going to, I think I'll get 45. Yeah, 45. Okay. Here's what I want you guys to do. Okay? For r equals 2 minus 2 cosine theta, 1, get dy dx, and then 2, get equation of tangent line at theta equals 45 degrees. Please do that now. Yes?
I just have a question. For like the dy dx of 2 sine theta times cosine theta, could you use the trig identities to change that to 2 sine 2 theta, and then when you take the derivative, it's easier?
Sure.
Okay.
Absolutely. Chris, do you see what Chris is asking? Chris recognizes this as sine 2 theta. And if you want to change this to sine 2 theta so that you're not having to do products rule, that's fine with me. Just, don't mess up. But yeah, absolutely. Okay, please do this now. I would please get dy dx by getting an expression for x, an expression for y, and then doing dy d theta over dx d theta, and then get the equation of the tangent line at theta equal 45. Just do that now, and we'll see how it goes. walk around and see if you guys are doing it. You need to do my work. Yeah, please. So did you get an expression for x and y? Now you're taking the derivatives, good.
Yeah.
And
But
then
then you have to,
Good.
so you start off.
An expression for x and y? Good. Now you take the derivative of that. The derivative of the second times the first, yeah. Good, good, you got expressions for x and y, now go ahead and take the derivatives of them. Make sure the y is on top. Did you get expressions for x and y? Yeah, beautiful. Now you can take the derivative of that. Great, now take the derivative of that. Yeah, good for you, Tom. Good, you got expressions for x and y, now you're taking the derivatives of them. You know, you hope you can do it right. But the first step is you gotta get expressions for x and y. Yeah, beautiful. I mean, I don't know if it's right or not, but you're doing the right thing. That's all I can do. Yeah, just cranking it up. Well, then I better start doing it so I can have it on the board for you guys. I'm going to change the homework assignment a little. I'm going to do 1 through 4. Yeah, I'm going to do that. I want you to do 1 through 4, and then 5, 7, 9, and 11. I think that's best. Oh my God. Okay, please look up. Did you guys get that for dy dx? Okay, if you did, that's wonderful. Now, let's go ahead and get the equation of the tangent line at theta equals 45 degrees. Well, step 1, okay, I need the point, right? I need an expression for x comma y evaluated at theta equals 45 degrees. So I need to plug into, where is it, my x and my y, alrighty? So let's plug in 45 degrees for my x, and I'm gonna get 2 times radical 2 over 2, so I get radical 2, oh, that's my y, but, so I'm gonna do my x first. So I get radical 2 minus, what is that, 1/2 minus 1? So I got radical 2 minus 1 for my x, and for my y, I'm gonna get radical 2 minus 1, right? Because radical 2 over 2 is 2/4, so yeah, minus 1. Got radical 2 minus 1. You guys okay with that as my x comma y? I had to plug into the very original equations for x and y, and I plugged 45 degrees. So sine 45 is rad 2 over 2, and then 2 times it is rad 2. Cosine 45 degrees is radical 2 over 2. Sine 45 radical 2 over 2. Multiply them, you get 1/2 times 2 make negative 1.
Wait, don't you get one? Yeah, you.
Okay, next I need my slope, okay? I need the slope, which means I'm gonna have to get dy dx evaluated at theta equal 45 degrees. Alrighty, well, let's go for it. So this is gonna be rad 2 plus 1 minus 1, okay? And here, this is going to be negative rad 2 plus 2. So I end up with radical 2 over negative radical 2 plus 2. Alrighty, so here it comes. Wait, don't go. Y minus rad 2 minus 1 equals rad 2 over negative rad 2 plus 2 times x minus rad 2 minus 1. Yeah, that'll be it. You know what? Can I tell you one more thing before you guys leave? You're going to get some problems that ask you to find the equations for the horizontal and vertical tangent lines of the curve. Okay? I'll tell you right now, if you want a horizontal tangent, you put the numerator equal to 0, and you're going to have to use your graphic calculator. If you want a vertical tangent, you put the denominator equal to 0. Let me write that down in words. Also, please do not do 5 or 7, just do 9 and 11. For a horizontal tangent, set dx d theta equal to 0, and for a vertical tangent, set dy d theta equal to 0. And I think you'll be able to do numbers 9 and 11. 5 and 7 I'm going to have to teach you tomorrow. So hey, good luck you guys. And say bye.